Every Claude Code session has a finite context window. At some point in a long session, it fills up. When it does, Claude Code runs compaction. The conversation history is summarized and the raw message are discarded. What the model knew about your task from the last 50 tool calls is gone. What survives is the summary, the current Claude.md, and whatever you type next. This episode is about designing your setup so that compaction does not matter. You will build two reusable templates, a task state file and a session handoff file, and understand the CLAUDE.md token discipline that keeps your context budget from being eaten by your own configuration. This is the most architectural episode in the series. I will use diagrams because the concepts are more important than the code. To understand why compaction is a problem, you first need to understand what actually in the context window. Claude Code context window is not just the conversation. It contains several things, all competing for the same budget. First, conversation history. Every user message, every assistant response, every tool call input, and the output, all of it accumulates turn by turn in a long coding session with hundreds of file reads and bash commands. This is the largest component by far. Second, CLAUDE.md content. Every time Claude Code processes a turn, it loads all relevant CLAUDE.md files. The global one in your home directory, the project level one in the repo root, and any subdirectory level ones, and they are relevant if they are relevant, of course, for the current task. Every byte of the CLAUDE.md, it's loaded every turn. This is not a time cost. It is a recurring cost per turn, multiplied by the length of your session. Third, file reads. When Claude reads a file using the read tool, the file content goes into the context. A large file read early in the session stays in the context for the rest of the session until compaction. Fourth, the tool results. Every bash command output, every MCP tool response, every grep results, all of it accumulates in the conversation history. The context window is finite. When the total of these components reaches the limit, compaction triggers. Understanding the composition helps you make deliberate choices about what to put in context and what to leave out. Let me show exactly what compaction does to the session state. Compaction is not a disaster. It's a design feature. When the context window fills, Claude Code summarizes the conversation history and discards the raw messages. The summary is shorter than the original. That's the point. This lets session continue. Here's the critical question. What survives compaction and what does not? What survives is the compaction summary, which is prose description of what happened in the session. The current Claude Code.md, it's reloaded fresh every turn, whatever you type as the next user message after compaction. What does not survive is raw conversation history, individual tool outputs, file reads from earlier in the session. The model no longer has the file content unless it raises again. Anything the model knew from the detailed conversation that is not captured in the summary. The summary is generated by the model from the conversation at the moment of compaction. It captures the broad shape of what happened, the tasks, the files modified, the general approach. It does not capture every specific tool output, every intermediate reasoning step, every error message from the 200 turns ago is gone. This means if your task state exists only in the conversation. For example, I told Claude what we are doing in the first message. Compaction will degrade and lose that state. The next turn will work from the summary, not the original specification. The correct response to this is not to avoid long sessions. It is to design your setup so the important task state in files, not in the conversation. The solution is the state in file pattern. Here's how I implement it. The task state file is the single most important pattern in this series. The idea is simple. The current task state lives in a file, not in a conversation. Claude writes to the file as it works. When compaction happens, the file is not affected. It was on disk before compaction and it's on disk after. Here is the template. 4 sections. Current task, done, next step, and open questions. Current task is one of 2 sentences describing what's being built or fixed right now. Not the full specification, just enough to orient a fresh session. Done is chronological list of completed steps. Each entry is a single line. What does done, which file was modified, what the outcome was. This section grows as the session progresses. Next step is single action. The next thing Claude should do when it picks up this task. This is the most important section for continuity. When a new session starts, it reads this line and begins there. Open questions capture anything unresolved. A decision that has been deferred, a problem that appeared but was not addressed, a dependency that needs to be checked. These are the things most likely be forgotten across compaction or session bundle. CLAUDE.md instructions that makes this work. For example, after every significant step, like file modified, test run, decision made, update the task.md file. Keep done current. Update next step to reflect what comes after this step. This is behavioral instructions, not a hook. But because it's in the CLAUDE.md and reinforced by the pre-compact hook timestamp, which we built in episode 2, it gets followed consistently across long sessions. For example, let's go to the Visual Studio Code, Context Management episode 4. In the Patterns folder, we have a tasks.md template. As you can see, the template has a current task, done, next step, and open question sections. The second template handles the harder problem, starting a new session from where an old one stopped. A deliberate session split is different from a compaction. A compaction happens when the context fails and Claude Code takes over. A deliberate split is a choice. You decide the session is complete, you write a handoff file, and you start a new session that reads it. Deliberate splits are underused. Most engineers treat them as a failure mode. They are actually a better pattern than relying on compaction to manage continuity. You control what is preserved, you decide what the next session should know, you discard everything that is no longer relevant. Here is the session handoff template. 5 sections. Task completed, files changed, current state, what was abandoned or deferred, and next session start instructions. Task completed is one paragraph. What was accomplished in the session, more detailed than the task state done list. File changed is a list of every file that was modified, with a one-line description of what changed. This is the git log equivalent for a session. The navigation aid for the next engineer or the next session. Current state is a snapshot. What was the system looks like right now? Test passing or failing. No regressions. What works and what does not. What was abandoned or deferred is the critical section. Every session generates decisions that were not made. Problems that were noticed by not addressed. This is where they go. Explicitly, for example, so they are not silently lost. Next session start instructions is a short ordered list of what the next session should do first. Not a full task spec, just first 3 to 5 steps. Enough to get oriented without rereading everything. In the patterns folder also we have the session handoff.md file. So there is a task completed section, files changed section, current state section, deferred, and next section start with the instructions. As you can see, this MD file session handoff is richer and more deliberate than the task state MD. Different tools for different transitions. Now let me cover the other half of context management, keeping your CLAUDE.md from eating your budget. Every byte of CLAUDE.md is loaded every turn. If your CLAUDE.md is 500 lines, that is roughly 10,000 tokens consumed every single turn. Before any conversation content, before any file reads, before any tool results, over a 200 turn session, that is 2 million token turns of CLAUDE.md content alone. The 3 principles of the CLAUDE.md token discipline. First, structural content pays for itself. A file map that helps Claude navigate to the repo, for example, listing the directories and their purposes, saves token downstreams because the Claude does not need to explore the file tree. Put it in. Behavioral pros rules do not pay for themselves. They add tokens and may or may not be followed. Be selective. Second, cut the wishlist. Most CLAUDE.md files accumulate rules that were added after a bad session and never removed. Always add tasks. Never use magic strings. Remember to update changelog. These are not instructions Claude follows reliably. They are tokens spent on probabilistic reminders. Move the important constraint into the hooks. Remove the rest. Third, use hierarchy. A 200-line project level CLAUDE.md is loaded for every task in that project. A 20-line subdirectory CLAUDE.md is only loaded when Claude is working in subdirectory. Put context where it's needed, not at the top level where it's always below. The before and after for this repo, the first draft of the CLAUDE.md was around 250 lines. After applying these principles, keeping all structural content, removing behavioral pros, moving constraints to the hook, it came down to 180 lines. Roughly 2,500 tokens freed per turn. Across a long session, that is meaningful extension of effective context budget. The last concept is when to deliberately split a session rather than let compaction manage the continuity. The default instinct when compaction hits is continue the session. Sometimes that's right, often it is not. Here are 4 signals that tell you a deliberate split is a better choice. First, the task phase changed. You finished implementing a feature and now you are starting the test phase. A new session with a clean context and a short handoff file is more focused than a compacted continuation. Second, the context is contaminated. A long debugging session leaves a lot of dead-end reasoning in the context. Even after compaction, the summary preserves some of that noise. Starting fresh with only known facts is cleaner. Third, the CLAUDE.md changed. If you update the project CLAUDE.md significantly during a session, a new session loads the updated version cleanly from the start. A compacted continuation has the old version in the summary. Fourth, you are approaching a critical operation. Before a database migration, a deployment, or a major refactor, write a handoff file and start a new session. You want maximum context budget for the operation itself, not a depleted budget from a work that preceded it. The operational pattern, it's a write session handoff MD. Commit or save all in progress. Start a new Claude session and begin with read session handoff MD and pick up from next session start instructions. Let me put all of this together into a complete session lifecycle. Here is how all 4 episodes connect in a working session. Session start. Claude reads the project CLAUDE.md. The architecture and workflows from episode 1. If task.md state exists, Claude reads it and orients on the current task. If a session handoff MD exists from the previous session, Claude reads that first. Session work. Claude takes action. Writes code, run tools, modify files. After each significant step, it updates tasks.md. The current task, the done list, the next step. This is behavioral instruction from episode 1 in practice. Pre-compact fires. The notification hook from episode 2 writes a timestamp marker to the state.md, task state.md. The session continues with a compacted context. Claude reads task state, which survived compaction, and resume from the next step. Session end. If this is a deliberate split, Claude writes session handoff from the current task state. The next session starts by reading it. Tool calls throughout any external data Claude needs. Database rows, file contents, API results, cames through MCP tools from episode 3. This keeps context lean. Claude fetches data when needed rather than loading it up front. This is the production setup. 4 episodes, 4 layers that stack. 4 takeaways to close this series. 1. Compaction is designed, not a failure. Design your setup to survive it. The state in file pattern is the answer. Task state.md file holds what matters. The pre-compact hook timestamps it. New session reads it. 2. CLAUDE.md has a token cost per term, not per session. Per term. Keep only what earns its place. Structural content pays for itself. Behavioral prose mostly does not. Imported constraints belong in hooks. 3. Deliberate sessions split beat compaction forced continuity. You control what the next session knows. Use session handoff MD. Start fresh when the task phase changes, when the context is contaminated, or when you need maximum budget for a critical operation. 4. The 4-layer stack. CLAUDE.md tells Claude how to think. Hooks enforce what Claude cannot do and save state before compaction. MCP service gives Claude the tools it needs. State files make context compaction irrelevant. No single layer solves the production Claude Code problem. Together they do. The templates for this episode, task state MD template and session handoff MD template, are in the production Claude Code repository. You can find it in my GitHub. And thank you for watching the series. Please hit subscribe and like button. See you in upcoming videos.